Hello and welcome to Angular Air. On today's show, we have panel members Patrick Stapleton.
Hey guys.
Amy Knight.
Hello.
And Gleb Bamatov.
Hello everyone.
Today's show is going to be really great. It's something I've been super excited about. We're going to be talking about state management, especially with Angular 2. And for that, we have a number of great guests. First of all, Victor Savkin. Say hi, Victor.
Hello.
And we're also going to have Dan Abramov and Rob Wormald on. They're going to be a couple minutes late. But we're going to start with Victor. And, you know, Victor, we started talking about this before the show started, and I think what would help everyone to kick off this discussion is if you could kind of give us your definition of, like, what is state? What are we talking about when we talk about state management?
All right, cool. So I think that it's important to, it's very hard to define such primitives as state, but maybe if I describe different types of state, it will give enough intuition to people to think about it. So I think there are different types of state in a typical application. So there is local UI state, something that a UI component can have and nobody else cares about. For example, a button can have a color property. So it has a color, and only the button cares, but nobody else cares. No coordination is required. You know, only the button can update that property. And it's fairly easy to think about this kind of state. The second type of state is application state or non-local state. So when you have different parts of your application, looking at the same chunk of data or making decisions based on the same chunk of data. So they have to be aware of it, and you have to coordinate writes and reads to your application state, because you can have concurrent actors sort of modifying it. And usually, such state is not purely UI-centric. It can be UI-centric. It can be some sort of toggle properties that everything in your application depends upon, but usually it has some sort of domain meaning, you know. So like if you're writing a to-do, whatever, to-do app is a bad example, but if you're writing a to-do app, like the list of to-dos will be your application state. And lots of parts of your app can depend on that list. And finally,
really quick, when you're saying application state, does that necessarily mean persistent state, like what you're storing in the back end?
No, like when I say it, I mean like non-local state, something that requires coordination. Like in a part of that application state or whatever, like non-local state, will be the persistent state, something you have to like push back to the server or whatever to some local storage. And I think a lot of techniques you use to manage your application state, or whatever, non-local state, work very well for persistent state. Because I think the biggest problem with state is not the state itself, but the fact that you need to do coordination when you modify it. Yes, that's why local UI state, like the color of a button, is so easy to deal with. You know, the button has its color, the button can update the color. You know, like everyone can do it. It's not a problem. You know, it's not hard to do. There are like pros and cons of different approaches, but we can all sort of figure it out. Whereas application state or like persistent state or whatnot requires coordination, and multiple UI components are modifying it at the same time or depend on it at the same time. You can multiple endpoints you have to hit to get this information and whatnot. And that's why it's hard. The coordination is hard, not the fact that there is state, you know.
So in Angular 1, I think the majority of our audience is familiar with that. And what are some of the problems with what you're talking about, the coordination of state within, like specifically like an Angular 1 app, even though this problem may exist in like all web apps, it might be useful to give some examples there just to like kind of solidify the concept.
The problem would be if you have your application state not stored in one place, but you have like multiple actors storing chunks of it, it's very hard to keep the state consistent. Yes, because consistency is a big deal. So if you have properties that are derived from other properties in your state, and if you don't have a mechanism to keep this like state consistent, so all the properties like aligned and whatnot, you know, you can have a situation where one part of your app is being updated, but some other part of your app doesn't reflect the change, because it depends on some derived state, you know. So you get out of sync, and it creates a very confusing user experience. Like a very naive example would be, imagine you have a list of to-dos, and somehow you store the number of to-dos or like the number of completed to-dos in a separate place, in a separate property. Then it is like one can imagine, yes, when you added a new item to your list, but you didn't update the counter. So you can see that there are like 4 items in your list, but the counter can still show 3 or whatever, you know, because you couldn't coordinate that stuff. Yes? And like this question was studied very well on the back and whatnot, you know. That's why you have transactions, and you can think about it like databases and whatnot. The coordination of those modifications is what is hard. And when you don't have the state placed in one, you don't have sort of one mechanism for managing it. It's hard to keep it consistent.
So, what are the ways that people have started to develop in order to manage this?
Yeah. So I think that what happens right now is, and which I think is wonderful, is that a lot of patterns emerged to make the state management easier. And so, like Redux probably is the most popular one, yes? But there are a bunch that are very similar. And there are a few core ideas that those patterns share. I can go through the core ideas if it's what you're asking.
Yeah, that would be great.
So I think that there are a few core ideas. The first one is, first of all, you store all your state in one place, and you describe it as one giant, in quotes, immutable data structure. So the fact that it's immutable is important. So every time anything happens in your app, you create a new instance of the data structure. So in this way, the state of your application is akin to a database. So you have the state as a database. You can query it, you can inspect it, you can make decisions on the state as you usually do when you look at the database. The second core idea is that the state is updated by processing some sort of actions. And again, it's very similar to a database. So you have a series of actions arriving, and you take the existing state and you create a new state from it, and a new action. There are a lot of good properties that fall out of this. We can talk about those later. But the core thing is that UI doesn't change the state directly. Instead, all your interactions in an app produce those actions, and then some separate actor, database-like actor, will make sure that those actions are applied to state, a new state has been produced. The third core idea is that there is some sort of function which is outside of your component tree that actually manages your state. And usually this function is some sort of reducing function, yes, because you take an existing state, you take an action, you produce a new state. It's very convenient to write your function in this way, yes? Everyone understands how reduction works. It's wonderful and whatnot, but it's not the only way. One can imagine a different way to describe that function, yes? But the core idea is that this function is out there, it's not part of your component tree, it's not being split into multiple chunks. There is one function somewhere else that takes a new action and produces a new state. And the last core idea is that your application logic and your view logic, because of this arrangement, are separated. So your view is just a component tree, just renders whatever is given, but your application logic is outside of your component tree in that state function or whatever. So those are the four core ideas.
Cool. And use this opportunity to welcome Dan Abramov. Welcome, Dan.
Hey, how are you doing? Sorry I'm late.
Yeah, no problem. So Victor was just going over some of the core ideas of Redux. So you are the creator of Redux. I'd be interested in kind of hearing, and Victor went over before you joined some of the problems that in state management in general. So I'd be interested in hearing kind of you to add on to that, why you created Redux and some some additional things that maybe Victor didn't touch on for the core ideas there.
Yeah. Okay. So I guess my motivation for creating Redux was I spent some time doing Flux in my application, in the application I was working on, and the reason we used Flux is not because it was popular or hyped or whatever. So we actually had those problems that Flux was supposed to solve. We used Backbone back then, and so we had a very straightforward client-side application built in React and Backbone. It was Backbone at first. We started migrating some pieces to React, but the model layer was still Backbone. And so it was pretty tough to teach Backbone, to do nested models, to teach it pagination, optimistic updates. So all kinds of user experience, nice things you want to have in your single-page apps. They were complicated because Backbone didn't have any built-in way of dealing with them. You had to override a lot of methods. And then it was often we wanted to do something asynchronously, but the logic was so complicated, it was very hard to reproduce bugs. So this was my biggest problem with Backbone, really. It was so hard to reproduce anything because like a trivial situation where you have a follow button, so the user can follow another user, and we want to increment the follower of being followed by counters on each user optimistically. But then if the request fails, we want to revert these changes. But then what if we press follow twice in this period? So we want to have some kind of is currently fetching this kind of state. And so it's very stateful. And if you mix difficult state with async handling, it's very hard to keep track of what's happening. So when we discovered Flux, this was we understood the need for it, why Facebook decided to come up with it. That is to have predictable updates that are possible to log. You can log every action. You can save it in a file. You can send the log to a developer and replay those actions and get the app into the same state. So it's completely reproducible. And I guess what I tried to do with Redux is improve on some parts of Flux that I found problematic, such as the inability to inspect the current state of the app, because in Flux, the current state is just held in local variables in different files, and you can't really kind of read them. And I wanted to develop a tool that would let me see all the state of the app, then see what action happened, and see the next state. So if I have a mistake, if the state is incorrect, I can take a look at the log and find exactly where it was incorrect. And because in Redux you compose your update functions, the reducer functions, out of other reducers, so it's like a reducer tree where every function handles some part of the state, what you can do is if you see that some specific like state that to-dos, that something is wrong, you know exactly which function returned the wrong result, because there is just one place of code associated with every key in the state tree. So you can look it up and you know that the problem is there. So you know which action caused the problem by looking at the log and which function caused the problem, which makes debugging and fixing bugs much easier. So this was my main motivation.
So you mentioned a couple of the details for how kind of Redux, your implementation, works, but I guess what out of that do you consider to be kind of the core concepts? Because I've seen both what you originally implemented, and then a lot of people take different takes off of it, like little variations, both within the Angular world and elsewhere. So what do you think are the most important pieces from the Redux pattern?
It's a great question. I think for me, what I consider to be the core ideas is that actions are serializable and they're plain objects. In other words, you need to be able to serialize the action log and be able to replay it later. So if you can serialize something to local storage and somehow load these actions from local storage and just replay them, and this gets the app into the same state, then I'd say it's the same pattern as Redux. And I guess the second part to this, which was really fundamental to me, is making hot reloading possible, because I like being able to iterate on the logic without kind of refreshing the app, getting it into the same state. So with Redux DevTools, which is like my other project that keeps the same Redux API, but adds some capabilities like being able to replace a reducer on the fly and have it replay all the actions with the new version of the reducer function. Again, if you can't do that, then I'd say it's not like Redux, because in Redux, since reducer is a separate function and it's stateless, it's just a pure function, you can replace it at runtime and somehow rerun the actions and see a new result. But these are, I guess, the two fundamental constraints that I had, because I did not really intend to create a library, so I was really preparing for my talk at React Europe, which is about hot reloading and time travel. So as long as hot reloading and time travel are possible, I guess it's compatible with Redux.
Okay, so given that, Victor, I'm curious how well you think that Angular 2 matches up or is able to fit into that model and some of the other core concepts that you mentioned earlier.
Yeah, so I think that you can use Redux with Angular 2. Like there is no, I don't see anything in Angular 2 that would go against like using Redux. Because fundamentally, if you want to use Redux, I mean, you can use it even with Angular 1. Yes, I don't think you cannot use it with Angular 1. But with Angular 1, you have one constraint or one problem, one complication. And the complication is, if you want to reason about an app that uses Redux, you probably want to have your data flow a little bit more constrained and well-defined. And when you have two-way bindings, because the whole point of state management is to make it as explicit as possible. When you have two-way bindings, as you do in Angular 1, and you use them everywhere, it's hard to keep your state management constrained. Yes, like it's just harder. So it is possible. Like nothing will stop you, but it is harder. So in Angular 2, because we have a sort of a more constrained form of two-way bindings and whatnot, it's a lot easier. So I would say it's just as easy as it is in React.
And I noticed that so some of the concepts maybe touched on a little bit, like unidirectional data flow is sort of a requirement, your underlying requirement for enabling Redux, that you have that path of be able to hook in the state management. So that's something that is sort of built into the core of Angular 2.
Yep.
So like, is that, when you guys were designing Angular 2, to what degree were you influenced by some of the stuff going on in the React community?
Sorry, can you say it again? I mean, the connection.
To what degree were you influenced by some of the stuff going on in the React community when you were designing Angular 2?
I actually, like, when I joined the Angular team, I joined at the moment where the decision about unidirectional data flow was already made. So I'm not sure what happened before. I'm sure like the influence of React was there, because like clearly unidirectional data flow works really well for a lot of reasons. One of them is like it's sort of easier to see how state propagates through your app, but also it's a lot more performant. And I think performance here was an important concern too. It wasn't just let's make it easier to reason about and whatnot, but like it also makes it faster.
It was all Vojta.
Yeah, like Jeff like is telling me that it's all Vojta. Vojta basically made the decision.
Jeff could join if he wants, but like so Victor, like yep. I don't know if you've seen any of the OhmNext videos, but basically like they were talking about a lot of like problems with OhmNext and what they're solving, and one of the constraints that they found was that with, say, like with React, like that it has unidirectional data flow, but that was actually something that they actually wanted to go sideways. They wanted actually to render sideways and like up and down, and they have this like this crazy graph rendering, and they were restricted in React because it had that restriction. So like with Angular 2, can you render sideways and left and right, and basically can you like change the way you render per se?
What do you mean you can render sideways? It's not clear to me.
I
was going to ask that as well, if we could define that.
Patrick's like going in his own.
Yeah, sorry, don't skip me.
Well, hey, Patrick, were you talking about just the component tree?
Yeah.
I mean,
that was a fair question. That was on the spot.
Yeah, so because sideways is not well defined, it's very hard to make a comment on if you can do it sideways. We can talk maybe after that, like offline, and then like post it somewhere.
All right, so getting back to Redux for a second. So Dan, I'm curious. We talked about some of the motivations, like the underlying problem, managing state, and what are some of the benefits, I guess, in addition to like I guess side benefits that when somebody takes this model and adheres to the Redux pattern, what are some of the benefits that they get out of that?
Well, I think we talked about some benefits like predictability, being able to record, replay user sessions, being able to it's easier to create universal apps that render on the server. I'm not sure what Angular 2 server rendering story is, but I think I read something about it. But anyway, it's easier to if you use something for server rendering like React, you can prefetch data on the server using the same mechanism, the same Redux store, the same actions, and then you can just call store get state, and you get this state tree that you can put as a JSON into your HTML, so that when your app boots up with a server markup, it can, when the JS is loaded, the Redux store can be created with the same initial JSON, so it's pre-populated and ready to kind of handle additional actions. So it makes creating universal apps that render on the server a lot easier because it's so easy to hydrate and dehydrate state. So I guess that's one of the benefits. I mean, another benefit is something I like in particular is it's very simple to implement some previously complex things like undo and redo, for example. We tried to implement undo and redo in Backbone, and it was a huge mess. And with Redux, it's easy because it's just a matter of wrapping the state tree, some part of the state tree that you care about keeping a history of. And in fact, there is a library called Redux Undo, which gives you a function. You give your reducer to the function, and it returns a reducer that will call your reducer, but also keep the history of previous states. So it's like a plugin for undo redo, where you don't even have to write any code to handle the history. You just plug in this library, and bam, you can have undo redo buttons that get disabled or enabled depending on whether there is history. You can show the history. So it unlocks some powerful state management patterns. And this is what I like about it. But of course, there are also downsides. Like if you'd like to speak about downsides, I can tell you about them as well.
Yeah, no, that would be great.
Okay, so there's actually a discussion on the Redux issue tracker. So it's active right now. You can go to Redux issues, and there is a discussion called "What are the disadvantages of storing all your state in a single immutable atom?" And this is a great discussion because I think a lot of people have been trying Redux for the first time for the past 6 months, and we didn't really have any insights from like where does this model fail, when does it get problematic. And right now we are, I think we're starting to have some reports on where it gets problematic and why, and it's, I think you should read that discussion, but to summarize some of the points. So it is not immediately obvious how to create applications with sub-applications, because in Redux state model you're supposed to have one store with a single state tree, but for bigger apps, for enterprise apps and complicated products, it's often the case that you want to have separate submodules that are kind of tied to the main app, but not exactly, and in React, this is solved with components. So you have local component state, and you don't really care like whether the children have any state, because you just render to them, and it's implementation detail of a component. But in case of Redux, you either have to export reducer and tell the parent app to mount it into the tree, or you have to agree that, okay, this sub app has its own store, at which point it gets harder to kind of synchronize things between these two apps if they communicate. So this is a trade-off, and this is something that people are exploring and coming up with solutions to, but it's worth keeping in mind. And another problem can be with giant lists, like if you have giant lists of data, which you shouldn't probably do because it's bad for DOM as well, and you should use some library that virtualizes the lists. But if you don't do that, it's React, at least in case of React, I'm not sure like what the situation in Angular is, but React lets you have optimization hooks that tell like there is no point in re-rendering this part of the tree because we know by reference identity that the state has not changed, so it's easy to bail out. But if you have giant trees, then even these bailout checks can get expensive. And you might want to have some more, some ways to subscribe to not just to the part of the store, but you might want to separate into several stores because there is just so many updates going on. So, like my official position in terms of the regarding to that is, if you have 50 updates per second, maybe you shouldn't express this as Redux actions, because actions are really what's happening in the user interface. So does your user actually update something 50 times a second? Like, why is it happening? Why are you not debouncing or throttling things? And but it can be a performance concern in some cases. So what I suggest is don't just go for the hype or ecosystem or whatever. If you adopt immutability and adopt a single state atom approach, what you should do is figure out the kind of memory footprint that you expect your data to be. Like, how much data do you want to have at the same time in the app? And figure out how often it changes. And write a stress test. Like, it's not hard to write an application that just dispatches random kind of actions that mimic what you expect your usage to be, and just check whether it matches your performance expectations. And only adopt a library after you've done so. This is like your homework if you adopt a library.
That's a good list of things to be aware of, for sure. What about, Dan, actually, is there potential for memory issues that because if you're having a single state and you have a huge app that and different things are adding different items to the single state tree, they aren't getting necessarily cleaned up when you're going from page to page or on the client side. So is that a potential issue as well?
Yeah, so in terms of memory, people often cite a concern with too much object allocation, but I would say that this is not often the case and not often the problem, because a common misconception about Redux is that you have to clone the whole state tree every time something changes because it's supposed to be immutable. But this is not exactly the case, because what happens is if you have a tree and something here changes, so this object changes, the object that contains it also needs to point to the new reference, so it also changes. So changes propagate up to the root object, but it does not mean that everything else changes. You can keep references to anything that is not affected to the current action. And so what you generally want to do is you want to hoist the often changing things to the top of the state tree, so it involves not too many object allocations. And this is an okay approach in most cases. And when you start hitting performance limits or too much memory trash, you might want to use something like Immutable.js that has structural sharing, so even modifying large lists is not as problematic in terms of memory allocations, because internally Immutable.js list is implemented as a data structure, and is a special data structure, and if you change, like if you append an element, it's going to change some parts of this data structure, but the rest are going to be the same. And this is not exposed to you as an API, it is just implementation detail, but it makes memory allocations much better with Immutable.js. And in terms of what you've been asking for, like caching and these things, yeah, this is something, like Redux is very low level. It doesn't tell you how exactly to structure your data and how to cache it and how to decide when it's time to prune the old branches. And indeed, I think in most examples we don't really prune the dead parts. Like if you go between the pages, what we want to do for best user experience is to cache all the lists and entities so you can have instant back button. But of course, it's a double-edged sword, because if you have thousands of items and you never refresh, it's going to keep adding more and more memory. So what I think, in most apps, you don't need to care about it, because people don't spend the whole day in your app. Like, this is unlikely. They are just closing tabs, and in most cases, it's fine to keep things in memory. But if you think this is, again, if this is a valid performance concern for you, if you are sure that people will spend days in your app without closing the tab, and if you have thousands of items that change every time and are being loaded, then you have to implement some kind of garbage collection by yourself. And I think the best way to do that would be to have some kind of higher-level library that lets you define a schema for your data, like user has comments, and comments have authors and likes, stuff like that. Define a schema, and then generate a reducer based on that schema that updates fields like in a database. And that, because we know the schema, we know when things stop referencing, when things become dead references, essentially. So, but this is not like, I didn't implement this. I have a project called Normalizer that lets you normalize a nested API response to a shape that is best for Redux, like a database table. But I have not implemented any kind of garbage collection for it because my use case did not demand it. So I'm hoping that maybe somebody will come up with that. And in fact, we're talking to Relay Team. I'm talking to Relay Team at Facebook, and we may try to come up with some solution that combines the best sides of Redux and Relay, because at this point we have these solutions that are best for server state and some solutions that are best for client state, but it's hard to augment them, hard to bind them together to ensure that you both have optimistic mutations, and then you have some mutations that are only local, and you have garbage collection. So maybe we'll see something come up in 2016. Maybe some of our listeners will implement that.
Yeah, actually, that would be pretty awesome. Is there an open source project for that effort?
Not currently. I think those who are interested can check out Normalizer, which is my library for normalizing the state shape. But I haven't seen any project that addresses this kind of this problem on a larger scale. So I'm happy to see that. If somebody has any links, please send them to me.
Okay. I wanted to switch gears and talk about one other kind of big aspect of this. Victor, in the Angular world, I mentioned earlier that there are kind of different variations of Redux over time that have started to kind of crop up. And one of the ones that's starting to become more popular is more of a reactive pattern. So the traditional Redux, when you are subscribing to state, you actually explicitly get state and then you set values, that you're using. But sort of the reactive model is a little bit different. So do you want to talk into a little bit of, what is the reactive patterns that are kind of developing within the Angular 2 kind of community?
Sure. So I wrote a blog post about it, so you can check it out on my blog, because I think that certain things are easier to actually see than for me to hand wave and like convince you that it works. But I will try. So basically, the pattern I described there was aligned with the core ideas I talked about a couple of minutes ago. So we still have application state represented as one giant immutable data structure. We still submit actions and process those to create new states. And we have a function, the state function, that takes an RxJS observable of actions and return an observable of states. And so it's kind of similar to Redux in a way, but it's not exactly the same. And there are a few important differences. First of all, the state function is invoked only once. So the purpose of that function is to create the observable of states. You don't even have to have a function. You can just like new and observable state from that. Yes, the observable, the application doesn't care about the function. Second, since we provide an observable of states and they are push-based, you can make certain action handlers async or sync without affecting anyone else in the application. Of course, there is a question if it's still pure or whatnot. So I mean, it can be pure. Like async doesn't mean it's impure or whatnot. And third, because we use RxJS to implement that function, to implement the state function, we can use all the combinators that this library provides. And this enables us to implement a lot of interesting interactions in a very straightforward and declarative way. An example I can give is, imagine if you have an application that emits some sort of action A. What you want to do is you want to wait for some other action B for a little bit, and then emit a new state. If action B doesn't arrive in, like, say, 5 seconds, you want to emit some error state. So if you use Rx to implement your state function, you can implement this interaction in just a few lines of code. And once again, I want to stress that the complexity of app state management, for me at least, comes from this need to coordinate things. And libraries like Rx are designed to make coordination easier. So that's why if you use Rx to implement your state function, a lot of coordination problems go away or become more declarative, because like the whole point of the library is to make them go away or make them more declarative. And that's basically what it is.
Okay. And before I do have a couple questions on diving deeper, but actually before we get into that, I'd be curious, Dan, for your thoughts, because just on the reactive form of Redux, that it is different. So, is that something that you kind of support and think is kind of a valid way of doing things, or do you think there's downsides to taking that as opposed to the normal, I guess, the one that you have built into the actual Redux library?
I'm not sure. I don't know, because I haven't tried it, and I don't fully understand. Like, I understand the Rex. I don't fully understand what this. I'm looking at the examples right now from that blog post, and so this gives you more freedom to kind of handle async things, I guess. But on the other hand, you lose the synchronous guarantees. So it's harder to say which update is caused by which action, because these kind of async reducer functions, they are free to skip some updates, to throw them away, or to make up new ones right in the middle. And so you lose this one-to-one mapping of which action caused which state update. And this was one of the goals of Redux, predictability. Like, I want to be able to find exactly where something happened and why. And this is a different approach with different trade-offs. So you can express things more, I guess, less verbosely. But on the other hand, you need some powerful debugging tools to kind of understand what's going on. And I guess when Rx has more powerful debugging tools, like something that shows me a graph of observables and how things flow through them, this wouldn't be a problem. But I haven't seen this such a tool like as a Chrome extension or something like that yet. So yeah, but I don't have enough experience with this, so I can't really say.
Actually, Victor, maybe that's something I missed, but is that the case that the reducers can be async, or is it just that you're binding to the store itself, which emits observables?
I mean, they can be async. I mean, since you're using observables, you can do sort of, you have the freedom to make them async. You don't have to, but you definitely have the freedom. So it's a fair point that if you make everything async, then it's harder to track what's going on. But you usually make things async because there is a reason. Yeah? So if you need to communicate with the server, some operation somewhere will be async. So the question is, how do you express it? How do you track? What went to the server, what came back, and whatnot. But yeah, so some action handlers can be async.
So I think, correct me if I'm wrong, Dan, but I think on the traditional Redux side, like the async you push to when the actions are before the actions are being created, right? That you do any asynchronous operations then and then actions. Is that right?
Yeah, so in traditional Redux model, the point is that you should be able to take the same action log and to be able to get into the same state, which is guaranteed if you have synchronous execution. But if you have async inside reducers, you'll be tempted to do async stuff there, like call inside the server, which introduces indeterministic behavior because it depends on your network conditions and stuff like that. And in traditional Redux model, for example, even the server payload is in the actions. So if you replay those actions, your app is not actually going to call the server. So this is how you can reproduce the user state even if you're you don't have the same server payload, because it's just right in the actions. And in terms of having a better way to do async stuff in Redux, I wanted to share a project which I think is interesting. I'm not urging everyone to abandon their Redux existing stuff, because this is the impression people get. Like, I advertise some project, and people say, like, oh, this is JavaScript fatigue, we have to port everything over. And this is not what I mean. I just think it's cool and it's worth exploring. So the project is called Redux Saga. and it uses the API is very minimal. Like it's just a bunch of helper functions that create objects, plain objects. But the idea is that you use ES6 generators, use generator functions to describe your async control flow, and it's not limited to promises. Like this is not kind of async await replacement, but it's more than that because it lets you describe long-running processes, kind of similar to CSP, to channels, where you take, where you can say that for every action, I'm going to take actions of specific types. I'm going to fire a request to this API endpoint, and I'm going to put different actions with this payload or whatever. And this is a nice way to declare it. And there is a Redux middleware that actually runs these kind of declarative instructions. But the best part about Redux Saga is you can easily test it because it's just generators. So you can create a generator object that it returns, and you can feed it fake data, and you can assert that the actions it returns correspond to what you expect them to be. And I think this is one of other things that are like fundamental to Redux is we want to make testing easier. And a lot of people told me that after Redux they started writing tests, and I'm so happy about it because it's just so easy to test.
Dan, I think they lied.
Yeah.
I'm just joking, but I think most people say they write tests, and I think that's a small fraction that actually do.
I know that, but it's like in Flux projects, like in Flux project boilerplates, normally you won't find any tests for Flux stores because it's just tricky to set up. You have to mark dependencies, but you will notice that in most Redux boilerplates you will find tests because they're so easy to set up because you just call the function and asserting that its output is what you expect, and you don't have to mock anything. And so with Redux Saga, you can do the same for async workflows, which is pretty awesome in my opinion.
Is that like along the same lines as what Koa is doing?
Like what?
Like Koa?
I don't know. What is this?
It's for the backend for Node, but it also uses generators.
It's like the next version of Express.
Yeah, right.
Yep.
Yeah, I remember that. Yeah, it's kind of similar. I think Koa uses generators for middleware and for passing control to the next function.
Yep.
But in terms, Redux Saga uses them differently. So it uses them to yield descriptions of commands that you want to happen. Like, I want to put this action into Redux store. I want to dispatch a request, or to call some API, or to fork a new process, or something like this. And then there's middleware that executes those instructions. So it's a little bit different usage. But this is why I'm excited about generators. I couldn't figure out why they were needed in the language. And now that they are in the language, I'm seeing some different libraries using them in wildly different ways, but that improve readability and the structure of the code. So generators are awesome.
That's cool. Victor, going back to reactivity second, and the reactive mindset, on the Angular side of things, part of the reason I was really interested in, today's discussion is because, just for even my own projects, I went through using, sort of the tradition of the actual Redux library and sort of the imperative way that it's doing some things, and then NGRX. So maybe if you want to describe, like, what are some of the major benefits specifically in Angular 2? When you're using the reactive model, there are some benefits to doing that specifically because with change detection and that type of thing. Do you want to talk a little bit about that?
And by benefits, you mean like performance benefits, or?
Yeah.
So that's true that Angular 2 can, as React can be faster if you use immutable data. So if you have an immutable data structure, we can actually skip huge chunks of our component tree when we do the rendering. But we also can take advantage of observables, or like RxJS observables. So if you actually bind in a template to an RxJS observable, we don't have to check that component unless that observable will emit a new state. So if you have a component tree and some part of the component tree bind to that state, and then you can say that, unless that a new version of the state was emitted, we can skip checking the component tree because clearly nothing changed, So in a way, it's similar to immutable data structures. It's just you do the same sort of with observables.
So Rob Wormald got pulled into a client meeting, it looks like. But he created a library, a reactive Redux-like library called NGRX. Do you want to tell us a little bit about that and how that uses some of these ideas in practice?
I'm actually not very familiar with NGRX, so I'm not the best person to talk about it. Maybe someone else can do it. Rob, yeah, but he's not here.
Well, I've seen it. Maybe I can say something. So,
yeah, sure.
From what it's going through some refactorings right now, which is awesome because they are motivated by wanting to have the same kind of dev tools that Redux has in React. So I know that Rob and some other folks are refactoring that to like some of the API decisions in Redux were driven by the need to have these dev tools. And I see that now Rob and company are realizing why certain things were made certain way in Redux, and are kind of changing their store implementation to do that as well. I think the biggest difference, of course, is the API I saw in the latest version is really similar to Redux. The main difference is that the store is a behavior subject, I think, and it has a subscribe method, which is, I think, is the idiomatic way of doing that in Rx. And in fact, if you look at some early Redux discussions, we were considering being compatible with Rx, but then we decided that we want to keep API minimal. And since people who use Rx are likely to be able to implement Redux pattern with just scan function in their on the observable, it doesn't make sense for us to cater to them. So I guess NGRX store is kind of like a middle decision where you have some benefits of Redux because it enforces you that you have a reducer function, and you can build an ecosystem around this kind of store, similar to how Redux builds an ecosystem around its store API. And the difference is just that subscribe returns a proper observable, which makes sense in a Rex world, absolutely. So I think it's a great project. I hope that we can figure out some way to not repeat the same code. Like in terms of dev tools, there is some complicated logic that would be best to share rather than copy paste. But I think we're on the road to that, and it's pretty awesome. Like it's a Rex first API for Redux, I guess.
It would definitely be awesome if the same dev tools could be used. That would be great. Yeah,
or at least if there is some large interop, like large piece that is shared, and we just have different kind of API facades to this piece.
We're near the end of the time, so I just wanted to mention if somebody does have questions for Dan or Victor, you can tweet us with the hashtag NGAIR, NGAIR. Victor, if you had to give some recommendations to Angular developers who are getting into Angular 2, what would you say for as far as state management goes? Like, should they just use NGRX and just follow like that library, or are there just more conceptual stuff that they should kind of keep in mind?
I think they should understand the conceptual stuff and understand the trade-offs, because as Dan pointed out, there are trade-offs when you pick sync or async, like reduction function or whatnot. So you need to understand why you're making this choice. And try a few libraries, maybe try to implement yourself, because it actually takes like 5 lines of code to implement a simple version of Redux if you use Rx. Just try a few things, spend a few days, and like pick whatever works for you the best. Like for me, Rx works the best because I know it, I feel comfortable using it, and like it gives me like a lot of power, which I can use when I want to. But yes, the downside is that the dev tools are not as good, at least not.
Okay, and again, one last question I had actually, and then if panel members have any other questions as well. One thing actually I was curious about on the Redux side, so I saw a pattern that if you're using the same object in multiple places of your state, that you might want to consider in some cases having like using an ID instead of like in the list, like you use the ID and then you have the actual object, just so you have the object in one place. It seems like there's some trade-offs to that. What do you recommend when you get to when you're doing something like that?
Yeah, so the only reason we don't do this in documentation is because people are going to be freaking out, like, what the hell is happening? This is so different from what we've seen so far. But I would recommend it for any serious application. You want to normalize your data because, so consider a situation when you load something from the server, and for example, you load a post, and the post has a bunch of comments, and comments have authors, and so this is a deeply nested data structure where some entities may appear at different levels. Like, for example, I may be author of the post, but I may also be author of the comment, and so the object representing me is repeated with traditional JSON kind of REST APIs. It is repeated in several parts, which is kind of a waste, but it's negated by gzipping. But it's still, if you just adopt this as your state tree, and if your state tree has several versions of a user object, and then you need to implement this change your name feature, and you're inside a single page app, so it's stupid to refresh when you change the name, right? So you want to update, if you're inside a single page app, you should probably update things right away. And so you need to change all these objects at different levels of nesting to point to change their name or any other field. And so this is super complicated, and this is why we never recommend you to have more than one object representing something that is unique in your state tree. So what we suggest is treat your state like a database. Your top-level state keys are like database tables. So you have users by ID, comments by ID, posts by ID, and their keys will be the IDs like 1, 2, and inside there will be objects like name 10, ID 1, like I don't know. In terms of, for example, for post, you might have something like ID 1, name, the name of the post, and then author ID 3, for example. So the difference is instead of referencing the objects, you reference the IDs. And it's also important that with single state tree, you can't really rely on referential equality between something that is in different parts of the tree. So you can't really do it the lazy way, like in traditional apps, where, like in Backbone, where you have some kind of cache that is lazily evaluated and kind of resolves to the same entity. So with Redux, it's supposed to be that you can serialize the state, deserialize it, and it should still work. But if you rely on different things pointing to the same object, it's not going to be the case. So we need to exclude that option as well. And what we have in the end is that we have objects in tables referencing each other by IDs, and before rendering the view, you want to denormalize the data in a way to make it look nice for the view, I guess. But it's best to do this lazily so you don't end up doing extra work. And again, as I said before, I wrote a library called Normalizer, which handles the part about normalizing the data. You just give it the JSON response. You define a schema saying that, okay, this response is array of users, where a user can contain, I don't know, comments or something like that. And it's going to walk the tree and give you a nicely formatted kind of response that is flat. Or otherwise, you can do this on the server and just send flat responses to begin with.
So one quick add-on question to this, so for Victor actually, because what you're saying makes a lot of sense, Dan. That, but it doesn't quite work on the reactive way of doing things. So like, because in the reactive way of things, you're have an observable on a particular part of the state tree, right? So like let's say you had an observable on a list of like my questions, and and some separate part of the state tree, you have one of those questions that you update. So if you have an observable on the list of questions, if either you have to handle updating that question in multiple places, or the ID thing won't work because you won't see it won't trigger the observable. Does that make sense?
But you don't want to. I think what you want to do in this case is it's pretty similar in React. It's just the same problem turned inside out, because in React you ask for you read the updates, but you still have to figure out if it makes sense to update the view. So what you want to do is you want to subscribe both to the to the tables that are affected, that like you care about in the view, and to the entity that is being rendered. And you have a function. We call this function selectors, but it doesn't really matter how you call them. This function accepts several inputs, like in this case, the like a table and the ID of the object you want to render, and it returns all the data that the view needs. It's like view model, where you return everything that is sufficient to render the view. And you can have something like distinct until changed, I guess, in Rx. But the idea is that don't reevaluate this function unless either of the dependencies changed. And you want to minimize the result to make sure that if the inputs were the same, then the outputs are going to be the same for performance, so that it's easier to in Rx to skip updates, or in React to bail out of updates because the references are the same.
Gleb, do you have a question?
Yes, I have a question. And first of all, excellent show, guys. Thanks so much for talking about Redux and Reactive. In your opinion, and this is a question for both, does it make sense to have more than a single store in your application? I kind of get the sense that you want a single store, but I definitely see some apps where, for example, a user management is separate store from the rest of the app, for example.
Yeah, so from my perspective, go with a single store unless you have problems with it, and in this case, add another store. So we encourage you to use stores not as a means of abstraction, but as means of performance optimizations. This is why we never recommend using multiple stores, but like if you have performance problems, you'll probably figure it out by yourself. In Flux, you use stores to separate logically different domains of data, but these domains often relate to each other, and so you have these dependencies between stores, and it gets really complicated. And in Redux, these dependencies are just handled by function calls, because function calls other functions and does something with the results. So Redux uses functional composition for abstracting away different parts of the state, but you can still use multiple stores if you have performance concerns. For example, some part of the data updates very often in response to a very specific action, and this action, no other part of the reducers care about this action, so maybe it's worth kind of hoisting that to a separate store. Or maybe if you have separate sub-apps inside one app and you don't want them to even know about each other, store can act as a separation boundary between these apps. So yeah, but we don't have any strict guidelines around it. It's just we don't want you to reach for multiple stores as the first kind of way to solve some kind of problem. But if you're sure that it's the way to go, please go ahead and do it.
Thanks, Dan.
All right, we're right at the end of our time. So there's one question from Twitter that I wanted to ask, and we'll ask this to Victor. From Mike Erickson, who's asking, how do you see Angular and React working together in the future?
Working together as like teams solving some like sort of problems, or as communities, because I think we definitely should work together as communities to like come up with good solutions and whatnot and reusable libraries. I'm not sure if you should use React and Angular in the same app. I mean, unless you like have to, like just stick to one thing, just do one thing, unless you have to use both of them.
That's a good answer. Any more questions from the panel members? Otherwise, we're going to go to picks. All right, great.
Yeah. So
go ahead, Patrick.
Yeah. So Dan, so you basically mentioned that with Redux that it's really good debuggability because it's all like synchronous code, and that's like kind of the point. So are you saying that with Redux you're pushing all asynchronous code to the edge of the application in order to? So that's kind of like what you're saying with RxJS, that like with RxJS, because it's synchronous by default, but you can make asynchronous calls inside of it, and it's so easy to do that that it leads you down this path of like, oh, well, I could do that, so might as well add more asynchronous paths. So in a way, you could do the same pattern of pushing all the asynchronous calls to the edge of your application and still maintain that. Similar to, I guess you could say with sagas and generators, like you're able to fork and add promises the same way as you would with RxJS. So I guess I'm just like kind of clarifying that, I guess. But like, what are your thoughts on Cycle.js and like what are your thoughts on Cycle.js? Like very briefly.
Okay, so yeah, so it's a good question. In terms of yeah, it's a fair comparison that Rx gives you more freedom, but it also gives you less constraints. And the point of Redux, and I think largely the point of React, is to benefit from constraints. So, for example, in React, there is always a source of truth in terms of props. In observable-based frameworks such as Cycle or other observable-based frameworks, the picture is slightly more complex, and they both benefit from it and have some issues because of it. Since there is no central source of truth, the state is generally, so to say, trapped inside combinators. And I'm not spreading Rx FUD here. Rx stance is that people are adult enough to understand what they want to be implicit and what they want to be explicit. For React and Redux, the goal was to constrain you in a way that if you do something that is not very good, it's easier to find this mistake. So I guess Cycle will, things like Cycle will be a more viable option for folks like me when they have better debugging tools and better ways to see what's happening with the console flow. And another point about Cycle that I want to, again, not trying to bash anything, everything is good, evaluate for yourself, but so what's been concerning me about observables, and I want to have more input on this, so if you're a person who understands observables really well, please get in touch with me and help me understand this. But what I've been concerned about is that the consumer, in this case, like the code that renders changes to the DOM, for example, the consumer normally does not have any way to constrain the producer, which may be several levels of observable transformation from it. It has no way to control the back pressure, like being able to say, hey, chill out, I don't need your updates right now because I'm busy rendering whatever I'm rendering, and I'm going to need an update like in 60 milliseconds, but not right now. So I'm not saying that Rx can't deal with that, because it can, like you have throttle, but it needs to be applied on earlier side. So this is something I'm interested in, how these kind of problems can be solved in Cycle and related frameworks without burdening the application developer, of course, because application developers are never going to think about this. Like, this is too complicated.
Victor, do you think you would agree with what Dan is saying as far as like that mindset? I mean, I guess it's trade-offs, but what's your mindset?
Yeah, in general, I agree. Like, it's a very complex subject, and I don't want to go into it too much. Like observables, not observables. I know people have very strong opinions about it. I don't want to like offend anyone. You know, clearly there are advantages in having like synchronous code running everywhere because you can reason about it. And the whole, okay, so like let's regroup. So the whole point of having synchronous code, why it's really good, and like right now in the browser, is that the whole tool chain is based around synchronous code. So if you like put a debugger statement, you go there, you see the call stack. The moment you have call stack, yes, it's good. You can reason about your code. You can step through. There is a lot of upside that you gain from it. But there are some downsides, and if you switch to observables, you lose all the upsides. Yeah, the tool chain doesn't work as well, but you get more power. Yes, so you should like understand this trade-off. Because if you don't need the power, don't take the power. You know, only if you need it, you should take it, because you will lose the whole tool chain.
Well, guys, it has been really, really awesome Patrick, did you have something you want to add on to that?
Yeah. So Dan, I'll get Ben Lesh to comment on that for you. I heard he does RxJS. Yeah, it's almost as if like during the development of your application, it kind of makes sense to go synchronous and then production go asynchronous. Because like for example, like so Jeff and I, we do server rendering for Angular 2. And one of the benefits of doing something like observable, or like one of the benefits of Cycle.js is that it's asynchronous, so you don't have the problem of blocking the event loop when you're rendering the application. So again, like it's more like trade-offs of what your priorities are, and yeah. So it's at the end of the day, like check out everything, understand the trade-offs, and then pick what's best for you.
Definitely, and that's a good note to get to our picks on. Definitely, it's been awesome, guys, to talk to everyone. So let's start off with picks with Gleb. Oh, Gleb, you're muted. No?
Sorry about that. So my pick is Rob Wormald. You know, even though he wasn't, could not make it today, but he has excellent videos talking about state and reactive state in Angular 2. So my pick are his videos. And my tip is that in reactive, everything could be a source of events: mouse clicks, user actions, search, pretty much timer events, everything that you can think of is just a source of events.
Cool. And Patrick?
Mine is that the creator of Webpack created called What's New in Webpack 2, basically listing all of his new APIs that is kind of like normalizing, because Webpack 1 is kind of like questionable in terms of the API sometimes, but that's pretty cool.
Awesome. Amy?
Okay, so my picks are just thank yous. I just really appreciate being on the podcast, because this is probably one of my last ones, if not the last one, depending on how next week goes. But I am starting a new job, and I don't know how much Angular I will be doing anymore. So I'm just really, really, really grateful for Kent for having me on the podcast the first time, and Patrick and Jeff and Olivier. You guys are all awesome. Really going to miss you guys. Maybe I can drop in if there's time. Maybe when I get up to speed at the new job, I can start doing some Angular 2 in my free time. But that's really my pick, because I am going to the other side for a while.
We're going to miss you as well.
Yes, till I can start doing some of this in my free time, but yep.
You're actually going to be working on Elm stuff, right?
I will be doing mostly React to start, and there is also some Elm there as well, but I will be starting off with React and Node, so
cool.
More Node, that's what I always do, but Dan's giving me the thumbs up, so I'll spill the beans on where I'm working soon, but it's with a friend. So.
Okay. Cool. All right, Dan.
All right, so I have a tip today, which is very simple. If you're a beginner developer and you're freaking out at all these ecosystem and all these tools, and you think, hey, I'm just going to clone a boilerplate project and evolve my app from that. My tip is, do not do that. Do not seek out the best boilerplates. Forget about all of that. Create the index.html file and slowly build your app from that. And you can look at boilerplates and you can learn some tricks from them. You can learn about what people like to have as build tools. But don't treat them as a gospel, because people maintaining boilerplates are doing this in free time. Often they don't use them for production projects. When there is some kind of weird error, it's often not because you don't understand something, but because it's just broken and not maintained. So forget about boilerplates. Pick some parts that you like from them, but mostly add tools one by one. And my picks today are going to be Redux Saga, the project I talked about. It's an interesting way of modeling async control flow in Redux. I suggested to check it out and get acquainted with generators, because this is the project that forced me to learn generators, and I like them now. And my second pick is going to be Aphrodite, which is a new library relatively new library by Han Academy, and it's another take on inline styles. And I heard that John Resig endorses it, but you should check it for yourself, and don't blame me if it doesn't work. But it seems pretty cool, so Aphrodite.
Awesome. Victor.
All right, so I don't have any programming picks, but I have a few non-programming picks. So my first pick is a book I read a couple of weeks ago, which I really like, called Mother Night by Vonnegut. My second pick would be an album I've been enjoying for a few months already, and it's an album called 10 Years So Alive by Brett Meldau. It's a collection of live recordings by Meldau, and it's exceptionally good. It's 5 hours of music. If you like solo piano jazz or avant-garde jazz, you should check it out. And finally, I rewatched a movie called Manhattan Murder Mystery by Woody Allen, and it's really good. It's really funny. It's well written. If you haven't seen it, you should totally check it out.
All right, thanks, Victor. I don't have any picks, but I have a couple announcements. First is that we have a new sponsor who's going to be Auth0 that we're really psyched about. We're friends with a lot of the Auth0 developers, and it's going to be awesome to have them on board and helping the show. So starting next week, I'll try to have the logo up and all that type of stuff. So thanks to Auth0. And our next show next week is at February 16th is at NGNL. It's going to be a live broadcast there with a number of panelists. I won't be there, but a number of other people will be on the show. Olivier, I think Patrick, you're going to be there, right?
Yeah.
Okay. And then the week after, February 23rd, we're having a show with Yuri Goldstein, who is the creator of Angular Meteor. So that's going to be a great show talking about Meteor's integration to Angular and Angular 2. That's it for this week. Thanks, everyone, for listening, and see you soon. Later.